Let us now try to understand Kepler's second law. So here we go with Kepler's second law. Kepler's second law states that the line joining the planet and the sun. Let me show you the diagram, children. So here is your elliptical portion. These are the major and minor line segments. Here we have the sun at one foci, and this is your planet. The line joining the sun and the planet. So this is the line joining the sun and the planet. So what this says is the line joining the sun and the planet sweeps out equal areas in equal intervals of time. Let me write down the statement. The line joining the sun and the planet sweeps out equal areas in equal intervals of time. So the line joining, this is your sun, here is your sun, and here is your planet. The line joining the sun and the planet sweeps out equal areas in equal intervals of time. Let us suppose that in some time, the planet has covered this amount of area. So earlier the position of the planet was somewhere here, and now the new position of the planet is here. So as the moment the planet moves from here to here, the line joining from sun and planet covers this portion of area. That green colored portion of area was covered by this planet. Okay, so this is the area covered by the planet. So how much area covered? Line joining from here to here. It's like this, it is there, it is moving something like, so some amount of area, this line covers some amount of area. That covers, I'm telling it as sweeps out some area. Okay, in some time, some amount of area is being covered. Let us take that some time as t. As the planet approaches the sun, let us suppose that now the presence of planet is somewhere here. Earlier it was here. After some time, the planet has reached here. Now, in the same amount of time, the planet would have moved certain distance, and let us suppose that the planet has moved this distance such that the line joining the sun and the planet must sweep out equal area in equal intervals of time. That means, if you observe this, this is the line joining sun and planet. So, this line joining covers now this large amount of distance. Okay, if you name this as some other area, A1 and A2, he says that area 1 must be equals to area 2. Here also planet is moving, here also planet is moving. Okay, so if it covers this A1 amount of area in t time, then it may cover A2 amount of the area in the same time. So he says that these areas are equal. That means A1 equals to A2. So the line joining the sun and the planet sweeps out equal areas in equal intervals of time. So this is your Kepler's second law. So how is it possible, children? The thing is that here it moves slower, whereas here it moves faster, so that the same amount of area can be covered. Same area. If this is A1 is A, A2 must also be equals to A only. So this is what he was saying. Same areas. Okay. So now let us also try to understand the Kepler's third law. So what is Kepler's third law says? Kepler's third law says that the cube of the distance between the sun and the planet. Let me show it.